It is known as BH loop, or is also known as hysteresis. Hysteresis means to lag. Go through A part only. We will perform one experiment in the lab. No doubt in the lab we take a ring, but here I will explain using a rod, a magnetic material, ferromagnetic material. Which material? Ferromagnetic material. It is in the lab, it is in form of a ring. Because of space, I will explain it this way. Then you have a wire surrounding the same, a winding. It carries current I. By changing this voltage, you can change this current. There are certain number of turns N. We have to plot a graph. Graph what? B and H. We will vary H. When you say H is what? Magnetizing field intensity. It is mmf per unit length. Number of turns is Ni is current, L is the length of the magnetic material. H. B is equal to magnetic flux. When the current flows in this winding, in this wire, because of this current, there will be magnetic flux. Magnetic flux is phi m. Cross sectional area is A. Then it is phi m by A. So you have to plot a graph between B and H, or in competition sometimes they ask between phi m and I, but phi m and I magnetic flux, N number of turns fixed, L length fixed, A area is also fixed. So the graph shape is same whether it is BH or it is phi I graph. 2 minutes. Experimental setup and graph to be plotted. One full page is required. Read one full page. Point O. O point. Yes, this point corresponds to what? What is the value of H? 0. There is no current flowing, there is no battery connected. Current flowing is 0. If there is a current flowing is 0, then H is equal to 0. What is the value of flux at this point? Magnetic effect is 0 because in the material the atoms are, or magnetic dipoles are randomly distributed. You have just purchased a ferromagnetic material from the market and the magnetic dipoles are randomly distributed. So result is 0. Now you slowly increase the value of current, 1 ampere, 2 ampere, 3 ampere, 4 ampere, 5 ampere. Because of this, the orientation will increase. So as current increases or H increases from O, this orientation increases. And at certain point, say A, this orientation is saturation. All magnetic dipole moments are aligned. That means at point A, it is like this. All are aligned, 100% orientation. You also call this as saturation. Further increase in current, if you try in the lab, will mean graph will be almost parallel to H. So we won't proceed after this point. We will come to this A only. So at A, I can draw the diagram here also, that at A, these are aligned parallel, 100% orientation or saturation. It is in this material. This material I have placed it here because I will change this photograph when I move to the reverse direction. That is why it will be difficult to draw here. So 2 points, point O and point A, and time with you is 2 minutes. As current increases from 0, orientation increases. At A, all magnetic dipoles are oriented. So you increase the value of 0, 1, 2, 3, you keep on increasing the current, say up to say 10 ampere. Suppose H is say 10. Now it is saturation. After this, yes, after this, you will decrease this current. If you decrease the current, flux also decreases. But it doesn't follow this route. This flux decreases. And at this point, say this point is B. Anyone who can explain? H you have reduced to 0. Current is 0, you can eliminate this wire. Still, there is some magnetism. Why? Residual magnetism. If in any container, any utensil, you have milk, then you empty this. After that also, there is some effect of milk. Agreed or not? This is known as the residual effect. Residual magnetism. That means you have reduced the value to 0, but still there is some magnetism left. That means it is of this type. At point B, that is this point, the material is of this type. Still it has some orientation in one direction. It is equivalent to this arrangement. Say this is straight, you apply a force. Now you remove that. I have removed the force, but still there is effect. Still the atoms or molecules are oriented in the same direction. In order to bring it back, what I need to do is, yes, apply force in opposite direction. Then you try to bring it back to the original position. So same procedure I will follow here also. Now, in order to bring it to 0, what should I do now? Yes, now you apply, change this polarity. Make this as negative, this as positive. Change the polarity, and now the current here H was positive, H is negative, means current is negative. Now apply H in opposite direction, and you reach at point C. What do you have at point C? Yes. What is the result at C? What is the value of B at C? 0. And it is same as that original position O, but you will have to apply H negative. Coercivity. Coerce means to force. You will have to force it in opposite direction. This is known as the retentivity, retention, residual magnetism. And this is coercivity, means value of H to be applied in opposite direction to reduce the value of B to 0. 2 minutes to write. Point B and point C. If I write this as plus 10, plus 5, this is a minus 5, this is a minus 10. Yes. So now you are applying this value in opposite direction. Minus 5, opposite direction, what you get? B is equal to 0. Then minus 6, minus 7, minus 8, minus 9. Then these dipoles will get oriented in opposite direction, and again you reach saturation in opposite direction. Say point D. How you draw the diagram for the same? What was the diagram for A? All magnetic dipoles towards right. In this case, all magnetic dipoles towards left. In this case, B was positive. In this case, B is negative. Means B is in opposite direction. Now all the molecules are aligned in opposite direction. Then next, again it is saturated. In case you proceed further, there is no use. So now you try to decrease the value of H, minus 10, minus 9, minus 5, and again you reduce the value of H to 0. Why? A, B, C, D, E. Still there are some atoms, molecules aligned in the same direction because of residual magnetism, retentivity. So now apply the force in positive direction to make it 0. Say F, and again back. So we need not write E and F because it is same. So write point D only. At 8 you can add on objective questions. OB is residual magnetism. They write retentivity, I write retentivity. So both names are there. Retentivity, Yes. They write retentivity T also, not a problem. O to C, coercivity. This is question number 4. This was A part. B part, question number 4, B part. Energy loss. When you apply alternating current, when you say alternating current means positive, negative, this is how the current keeps on oscillating. When the current is positive, H is positive. When current is negative, H is negative. That means if you apply alternating current, this cycle, alternating current, positive cycle, then you get a negative cycle. All domestic application, fan, you have noticed, fan also gets heated. Now we will have reason why. It is magnetic material. Inside you have a magnetic material, ferromagnetic material. So when you have a ferromagnetic material, magnetic moments or molecules in this get aligned in a particular direction. So when voltage is positive, H is positive, we move to this. When then this value decreases, it becomes negative, so we'll move to the left turn. Then again positive, negative, positive, negative, positive. During these cycles, what is the status of the dipoles inside? Say this is the initial condition, positive all are aligned towards right. Then when you start putting up negative, then they start aligned towards, as seen by you, towards left. How many times in domestic application in India? 50 times in 1 second, 50 cycles per second. In US, it is 60 cycles per second. So just think of, if you do it like this, how many times? Just try. Yes. Let us come out with the outcome now. Do it fast. Still we are able to do it maybe 5-6 times in 1 second. But if you do it 50 times in 1 second, then the heat generated may cause burns. Agreed or not? That means this process of orientation towards right, then left, leads to what? Generation of heat. So heat is generated due to molecule or dipole orientation change number of times in 1 second. And this area, let us see what this area is equal to. Area of the graph. If this is B, this is H, then area of the graph is equal to B into H. Am I right? Like, if it is velocity, this is time. Area under velocity time graph gives you displacement. Agreed? So if it is B, it is H. Area under the graph is what? B into H. Any formula, B and F. F is equal to BIL. Agreed? F is equal to BIL. B is equal to what? F by IL. H is equal to number of turns into current by L. Number of turns is just a number. I and I cancel. Force. Length into length is what? Area. If I multiply and divide by length, force into length or force into distance is what? Work. Area into length is what? Volume. It gives you what? Heat loss per unit volume. So that means the materials, those will have high value of BH loop. Area is more. Losses will be more. One disadvantage. Loss of energy means more electricity bill. That is why a 5-star air conditioner will use a magnetic material, ferromagnetic material, for which the area is less. So that losses are less. Your electricity bill is less. But these materials are expensive. So you will have to spend more money when you buy it. That means there is capital investment. Initial money is more. 3-star air conditioner 20,000. 5-star air conditioner 25,000. Fine. So you shell out more, 5,000 rupees more in the beginning. But you save on a regular basis. Your monthly bill will come out to be less. That is why the question is, alternating current machines should have BH loop area small or large? Small. 1. 2. If it is heating, regular more heating, so the machine is heated too much, then cooling, too much of heating, cooling, because it's thermal stress. Machine is subjected to lot of thermal stresses that causes aging. That means this material with large area machine may work for 20 years, and the machine with a small area may work for 30 years. That is why material with a large area alternating machine will have less life. That is what we mean by the term quality. That it will work up to what? Time with you is 3 minutes to write.